Okay, this is my case annealer mounted on an XL650 Dillon, and there's some 308 cases that have been processed. I'm just showing what I've done. May help someone out. Basically, I have a coil made out of number 12 Romex wire. Just take it apart, and it was formed around a, what is this thing? It's a 11 millimeter 1/4-inch drive, and I'll put in the description, you know, this came from this not me that invented doing this way, although a lot of this is mine here. But so I have a fan that assists the coil in staying cool. If you're running it with a progressive press, you know, so you're going probably about this speed. You'll get through about 10 cases, and then this coil will get super red hot without the fan. And what that means to you is if you do actually melt the coil, it's going to destroy the electronics in this. There's a video guy shows how to fix it. It's involved though. There's a lot of diodes that need to be replaced when that occurs, so you really don't want that to happen. You have the fan running there, that coil will not overheat, and this is like a little server fan, so it's got a fair amount of go. It makes some noise when it's running. The base, this is a remix of someone else's base design. I just didn't want to take the time to design it myself. This is an earlier version of it. The only problem with it is it's not quite wide enough in his design, and so the pinholes, you need to widen one of them a little bit, and the pinholes that I'm referring to are this little mount right here, the little mount here. It's a little bit of resistance because it's a tight fit, but you don't need to use both pinholes if you don't want to. There's one on the opposite side, but it could use like another, like maybe 1% of width in the design, but it's not a big deal. You fit it for 5 or 10 minutes and then it fits just fine. On this thing, I'm using this switch right here to tell it to tell the control box when to activate. It's a relay, and then the control box routes power to the inductive heater, and then I have a cooling fan at the top. I can't see it in my little camera, but I have a cooling fan there, the pancake fan. I tried several different types of fans. This fan, for example, they just don't push enough air. You know, they just don't. The flat style fans just don't make enough air pressure, but this thing does really well. I'm holding a tripod, and it's kind of awkward. I don't have the correct tripod with me. So anyway, so there's a switch there that tells it when to start. That switch? Yeah, it switched. So like if you're running this thing, it's a regular press. You're gonna plug the power in. It's gonna make some noise. I can get this in there. Come on. All right. Fair amount of noise, fair amount of wind. And down here, looks like it's set to 3.3 seconds. I need to hit it twice. Goes into a coffee can held to the base with the powerful magnet. The coffee can has something that just So it's a little bit of padding. It's, I think, maybe a ceramic mat. But anyway, it doesn't burn, it doesn't make a bunch of noise when they drop in. We'll show that again. Of course, you'd be using the hopper on the top, right? This is just a demo. Watch the coil. Oh yeah, I think you can see a little bit of red there. So this was like my mock-up of how it would work, and this is way more involved than you need to go actually. But basically, I'm using I think it's the red and the black wire, which goes to this little 3-pin header here, and what that does is that tells it when to actuate. It's connected to the switch, or I think I referred to it as a relay earlier, but it's actually a switch. And that tells the timer when to start. It's better than using the, I think this thing you could do the same with the off and on, but there's a difference in the function. It's preferable to use this to activate it with the switch. And all it does is you have, this is a solid state relay here, and on your little header down there you have a plus side, negative side, and then these are the relays, the relay. And I don't know, maybe if you look at it you can kind of get the picture of what's going on. Basically, when the relay trips in here, it allows power to actuate this switch, and your 110 side is switched on, which turns this guy on. And it's been over 1,000 cases, and this thing seems to like that setup just fine. Doesn't burn anything out. It is overkill. You could actually provide this thing with 12 volts of power. This thing I'm talking about, with 12 volts of power. You could probably take the on and off switch, which I have held down with Velcro right now. You could probably take that and open the thing up and bring the wires out and run them directly into this box. And all you would need is 12 volts and some sort of a mount to make it work. But I did it through the power bit. That's pretty much it on this thing. Let's see what else. Again, this box is way overkill. I have fan power coming out of the box. You do need a lot of airflow. And this thing, that fan on the top provides a lot of airflow through this, so you don't have to worry about the innards getting overheated. Although it supposedly has protection for that works pretty well. But the fan was really necessary because the coil just simply, you could run past your, you could overwhelm the coil with heat. So if you happen to have a 650 that you can use, this would all come off of this with a couple of pieces of Velcro, the pins pulled out side to side. The problem is, you know, like you end up with a lot of stuff over the years, and where do you actually store all of these little bits and pieces? But I'm going to be uploading this to Thingiverse, probably XL650 case Annealer, something like that, Dillon. And I went, you know, there's an extensive amount of detail. There are probably other presses that you could do this on just fine. You could probably make something for one of these. In fact, I've seen videos where people did that. But if you use these two switch wires to work as a switch for this thing, you know, to activate it, that's really handy. And there's something, I don't remember what it was, there was something about if you use those two wires, I think, like, it doesn't, there's something about it doesn't interrupt the cycle. I don't remember exactly what the benefit was, but it's a big benefit. So it works how you'd expect. And using a 3D printer, really handy for stuff like this. Like you can design a mount and stuff and get it just aligned just exactly how you want to. And then where you see the screw hole back there, I printed a separate mount where that screw hole was set up to be a drill bit guide. So I could take this part off, stick that guide on it, and I would have the exact spot on this to drill the hole. So there was really no risk of an error in drilling the hole, which is super handy. So all of that will be included on the Thingiverse thing. There'll probably be like 1 or 2 people that want to build this, but it's pretty awesome in use. Just think how fast you go when you're reloading. Well, this thing has a 3.3 second delay right now. I played with different speeds and so forth. I don't know if there's advantage to one over the other. The main advantage of this is this is Lake City brass, and so it's a hard brass, and if you anneal the hard brass, it's much easier to get consistent sizing. I mean, it's not match ammo, but it's much easier to get consistent sizing if you anneal it first. Otherwise, and it's also helpful to sort your case heads too, since usually you buy 1,000 and there are several different head stamps for a year. But a lot easier to get accurate head space if, you know, like me, I'm loading for several different rifles, so it's a lot easier to be super consistent if you anneal your brass. And this thing goes, I mean, it just goes. You know how fast a progressive press works, and it's like that with this, although it's a 3.3 second pause. So so it's a little slower, but it's pretty darn fast. Alright, I think that probably about does it. I'll have more details on Thingiverse. This will make a little more sense there. But this is just, I don't know if I trust this little teeny relay here. And so I just send a few volts from this guy to the solid state rate relay, telling it to turn on. And you see I can go from 3 volts to 32 volts, and I think this thing's running at 12 volts. This part, so it sends it 12 volts. Light comes on, AC is connected. You could dig into the switch on this thing, bring the wires out, and probably just run those wires directly into this. Although it is, you know, a Chinese product, so I'd want to at least check the voltages on those wires and make sure that there's nothing crazy going on, that it's just simply an open and a close and no high voltages present. But that would be the most easy way. This is the most common style of body. I have the round one too. I haven't done anything with that yet. This thing is way, I mean, you can easily melt this brass. All you have to do is put it up to 4 or 5 seconds and it would start to collapse. So this thing works very well. This is PETG, the Bamboo Labs, their fast one, whatever they call that. It seems to work okay. It's good and strong, although you could definitely smack this thing and it would easily yield to you, so you have to be reasonable, but it's okay for this purpose. Coil's pretty easy. It's usually a longer piece of wire than you think, you know. But you know, and I talk about in the document I've written up for Thingiverse that tells you how many turns and how I figure out what a turn is and isn't, you know, so that you can get kind of close. But there's no going wrong. You're just going to adjust your time a little bit. It works well. So I think I've rambled enough. And the cat wants out. I know.